more than two roads meet at a particular point. Okay, so road intersection is where two or more roads meet and are the points of potential vehicle conflict. Vehicle conflict means there are different type of conflict, like merging conflict. Merging conflict means whenever two vehicles are about to just merge with one another, okay, or about to collide. Now, they are critical element of road section. Why they are critical element? Because in the intersection only, whenever a driver want to change its path, okay, they can change the road section or they can change the route through which they want to go. Now, they are normally a major bottleneck to smooth flow of traffic and major accident spot. Why bottleneck? You know the shape of the bottle. Now, the shape of the bottle would be like that. Okay, so bottleneck means in the intersection area, generally there will be some traffic jam if intersection is not managed well. Okay, in that case, what will happen? All the traffic or all the vehicles coming in the intersections will be congested in the intersection area. Okay, and that would be formed like a bottleneck. And whenever they will leave the intersection, then again their path would be like that. Okay, so this is basically a bottleneck position, and as there are different roads merging with one another, therefore there are vehicles from different directions, and for these reasons there are chances of accident in the intersections. Now, the objective of the intersection design is to regulate traffic operation and ensure safety of the road users and to maintain design speed and maximize the capacity of the intersection. So that is basically the objective of the intersection design. So whenever you are designing an intersection, in that case you have to keep in mind that what are the amount of traffic which are coming out from different roads which will be meeting with one another. Okay, so based on the traffic conditions or based on the number of vehicles which will be merging at a particular intersections, you need to design that particular intersection. Okay, based on that data. Now, what are the guiding principles? There are different guiding principles which affect the intersection design. So, first one is human factors. So, human factors are there are different factors which affect the human characteristics whenever they are driving their vehicle in the congested situation. Now, accommodate reasonable road users' characteristics. For example, design should follow proper geometric layout so that hazardous movements by drivers are eliminated. In the intersection design, you have to provide adequate side distance, and if possible, then you can provide some more distance or more visibility to the intersection, okay, so that all types of hazardous conditions can be avoided. Then traffic considerations are there, that traffic consideration that minimize the number of conflict points by separating some of the crossing, merging and diverging conflicts. So what are these crossing, diverging and merging conflicts? We will discuss this later on in this class. Then functional intersections area. So this functional intersection area provide adequate space at the junction. Functional area means at the portions where that traffic changes its route. Okay, that is the main portions of the intersection. And there are different physical elements like your different traffic island. As we have discussed in the previous class, there are different merging and diverging island. Okay, and there are different elements which can be called as physical elements. Then economic factors is also associated with it. Like suppose for a plain intersection there is not so much cost associated with it, but if you want to design a overpass or underpass, therefore that cost required for that intersection would be higher. Similarly, if you go for a the signaling system, in that case also cost may be higher. So you have to think about different scenarios and you have to justify the cost through which or on which you will be designing the intersection based on the traffic scenarios persisting over there. Now there are different type of intersections. So primary, there are two types of intersection, that is intersections at grade and another one is grade separated intersection. Now at intersection where all roadway joins or cross at the same level, they are intersection at grade. Okay, suppose we are considering one simple intersection like that. So see, in that intersection, two roads meet with each other at the same level. Okay, at the same level. So these type of intersections are at grade intersections. So this is a simple intersection. Now suppose there is a rotary intersection. In that case also this is a at grade intersections where two or more roads will meet at a same level. Okay, now there are another type of intersection which is called grade separated intersection. Now in the grade separated intersections, two or more roads will meet at different elevations or different levels. So for example, there are underpass pass or overpasses or overbridge, whatever you can tell. Then if we discuss about the at-grade intersections, there are different basic requirements when we can go for the at-grade intersection. Now first point is the area of conflict should be as small as possible. Area of conflict means the area where different vehicles will meet or there are different possibilities of conflict of the vehicles. So that area should be minimum. Then next point is the relative speed and angle of approach of the vehicle should be small. Now coming to the angle of approach, let us discuss what is angle of approach. Suppose this is the path of a particular vehicle. Okay, now suppose another vehicle is coming in this direction. So this angle is basically angle of approach. Now if the angle of approach is more, in that case there would be chances of severe conflict. Okay, now what happens, suppose this is a vehicles and this is another vehicles, and if the angle of approach is more, in that case there the severity, if accident happens, severity of the accident would be higher. Now as the angle of approach becoming higher, okay, in that case at some point there would be chances of head on collision. Okay, therefore it is always advisable so that the angle of approach is minimum. Now if the angle of approach is minimum, in that case if there is some conflict, in that case that conflict or that accident, severity of the accident would be minimized. Okay, that is angle of approach. Then adequate visibility should be available for the vehicles approaching the intersections. Now if adequate visibility is not provided, in that case the driver in a particular lane could not see another vehicles which will be approaching or which are approaching from another route. Then sudden changes of path should be avoided. You know the intersection area is very much hazy area. Okay, so in such area, if any vehicle suddenly want to change its direction or suddenly change its lane, in that case it would become more hazardous. So for this reason, it is always advisable so that all these vehicles cannot change their path suddenly. Then geometric features like turning radius and width of pavement should be adequately provided. You know that in the intersection there would be chances of traffic congestions, so it would be always better so that the intersection area is of a higher width than the normal road section. So in this way it can accommodate more vehicles. Then proper sign should be provided if there is needed any sign. Suppose some vehicles need to stop over there, in that case you need to mark over it. Suppose in some cases you may observe that some intersections are traffic police operated, and in some cases the vehicles in a particular approach need to stop over here to make way for the vehicles coming in this direction. Okay, so in such cases if the vehicles needed to stop at a particular positions, in that case you have to provide adequate road markings so that all the vehicles can stop at that particular positions, and you cannot allow any vehicles to crosses that particular mark whenever a traffic police or whenever a signaling system signal to stop for that particular approach. So therefore the sign provided over the intersection should be very much clear and understandable. And good lighting as in the night is also advisable or desirable for the swift operation of the intersection. Now, at-grade intersection may be classified into below groups. There are different classification for the at-grade intersection. First one is unchannelized intersection, then channelized intersection, and there is a special type which is called rotary intersection. Now, unchannelized intersection is that intersection which are very much plain intersection where only two or more road will meet with each other, and where no channelizing island will be provided. So in our previous class we have discussed about the channelizing island. So in the unchannelized intersection there would be no channelizing island. So what is this channelizing island? Okay, see, these are the channelizing island, okay, which enable the traffic to, or which force the traffic to make into different channels whenever they are trying to move into intersection. Okay, so in the unchannelized intersection this type of channelization would not be there, and that would be a plain simple intersection like this one. Okay, there would be no channelization, nothing is there, only simple plain intersection. Now, in the unchannelized intersections area is paved and there is absolutely no restriction to vehicles to use any part of the intersection area, as there are no channelizing island, therefore they can use any of the intersections area. So therefore, the unchannelized intersections are the lowest class of the intersection because they can manage the traffic at some extent, but not to a great high or great extent. Okay, their management of the traffic in the intersection is very much low. They are simple, basic intersection. They are easiest in the design. Why they are easiest? Because there is no element, nothing extra element is provided in the unchannelized intersection. Therefore they are very much easy to design, but the traffic operation in the unchannelized intersection is very much complex because it is very much difficult to control all the vehicles whenever they try to move along all together, and there in some cases there may be chances of traffic accident and huge traffic congestions if the number of vehicles increase tremendously for a unchannelized intersection. Therefore, unchannelized intersections are suitable at a place where traffic volume is very much minimal, it resulting in maximum conflict area and greater number of accidents unless controlled by traffic signals or police. So therefore, in suppose you have designed one unchannelized intersection for a particular area, and at the time of designing you didn't predict the increase of the vehicles in near future. So what will happen after some times, you have observed that number of vehicles in that particular intersection has increased with a tremendous height, and therefore they need to regulate. So to regulate the unchannelized intersection, you had place some traffic police over there who will control the unchannelized intersection manually, or you can insert some traffic signaling system which will control the intersection automatically. Now, these are plain intersection. There is no provision for additional pavement width for the turning movement, and flared intersection, there are provision for additional pavement width for turning movement. So in the unchannelized intersection, it may be flared or it may be plain intersection. So how a plain intersection would be? So a plain intersection would be like that only. This is a plain intersection. There would be no pavement increase in the pavement width in the intersection area. Now how a flared intersection would be? A flared intersection would be like that. Suppose this is the intersection area. So the intersection area would be higher than the normal road width, so that a vehicle can easily move from one route to another route swiftly. Okay, so there are two types in the unchannelized intersection: plain intersection and flared intersection. Now, based on their forms, there are different type of unchannelized intersection. So, see the pictures. I think these pictures are visible to you. So, first one is T intersections. So, this is a straight road. It is meet with another road at a 90-degree angle. This is called T intersection. This is called cross intersection. Okay, this is staggered intersection. This type is staggered intersection. This some portion of the staggered intersection you can see in the 6 mile area. Then skewed intersection. Okay, this will meet with the main road with some angle. This is skewed intersection. This is skewed cross, and this is skewed staggered intersection. This is Y intersection, and this is multiple intersection. So basically this multiple type of intersection is not suitable for unchannelized intersection. See, these are the flared intersection and these are the plain intersection. This is plain, okay, these are flared. Now, next point, traffic conflict. So first one is merging conflict. So merging conflict occur when vehicles enter a traffic stream at some angle. Okay, so see, if this is your main traffic lane, so in the merging conflict, some vehicle will try to enter the traffic stream at an angle. Okay, so basically this vehicle is trying to merge with that stream. Okay, so therefore this is called merging conflict. Now another type is diverging conflict. So in the diverging conflict, what happens? Suppose this is the existing traffic stream. There are different vehicles which are moving in this way, and sometimes some vehicles try to leave that traffic stream. Okay, this is called a diverging conflict. So they try to diverge from the existing traffic stream. So it is called diverging conflict. Then coming to the next, crossing conflict. So whenever two vehicles or two streams try to cross each other, suppose this is the existing stream, now another vehicles or another stream try to cross the path of the existing stream. This is called crossing conflict. And the last one is waving conflict. So basically here this two stream is changing its lane and make one crossing conflicts over there. So this is waving conflict. So among these, the most dangerous one is this waving conflict is very rare. Among these three, merging, diverging, and crossing conflict, the most dangerous one is crossing conflict. So as an engineer, your first task is to reduce the crossing conflict at a particular intersection. Now, if we calculate the crossing conflict or merging conflict or diverging conflict over a particular intersection, in that case, we can found that you can also draw in your handbook if you wish to. Suppose this is the road and this is the path of the vehicle in this direction, and this is the, sorry, suppose this is a T intersection. Okay. Now, in that road, some vehicles will be marching or diverging from this existing lane and will go in this direction. So here, one conflict position would or will generate. This is the conflict position. This is called diverging conflict because some vehicles from this existing lane is changing its route and is going into that direction. Okay, now another type is there. Suppose this is another vehicle. Okay, it will cross this portion and will merge with this. So there two type of conflict will generate. So here one crossing conflict will be generate, and here another merging conflict will generate. Okay, now similarly, if suppose there are some vehicles, if it tries to cross and is trying to going in this direction, therefore there will be some conflict. So this portion is your diverging conflict. Here some crossing conflict would be there, again in this direction another crossing conflict would be there, and in this portion another merging conflict would be there. So I request you to draw this picture and find out what is the total number of crossing conflict, merging conflict, and diverging conflict in this intersection. After this, you can try to find out what is the total number of crossing conflict, merging conflict, and diverging conflict in a crossing intersection. Crossing intersection means like that. Suppose this is an intersection, you can find out what is the total number of crossing conflict, merging conflict, and diverging conflict in this portion. So you can draw this. So you can try to find out what are the different type of conflicts existing over there. So next portion is generalized intersection. So in the generalized intersection, there will be generalizing island which will generalize the entire traffic stream. Now separation of the conflict movements at intersection to definite paths of the traffic flow by means of lane marking island, road curves or other is called generalization. So basically you are generalizing different conflicted traffic through different generalizing means, like generalizing islands, suppose some markings, pavement markings or road curves, etc. Now, generalized intersection is achieved by introduction of island into the intersectional area, thus reducing the total conflict area available in the ungeneralized intersection. These islands help to channelize turning traffic, to control their speed and angle of approach, and to decrease the conflict area at the intersection. Now, in the previously, this was a T intersection. For the T intersection, you have found out what are the total number of crossing conflict, what are the total number of merging conflict, and what are the total number of diverging conflict in this plain T intersection. Now, similarly, you can find out what is the total number of conflicts in this generalized T intersection, and you will find out that the number of crossing conflict in the generalized T intersection will be significantly reduced. See, in the channelizing island, as a central small rotary section is provided, so these vehicles will be going in this direction, and previously they will simply make some crossing conflict, but they will here merge with that existing traffic. Then again, suppose this is the traffic stream, they will merge over there, and at another point they will diverge from here, and again they will merge in this portion. So see, using this generalizing portion, you have reduced the number of crossing conflict over that particular area. Okay, so this is the benefit of generalizing in the intersection, and this is the usefulness of generalized intersection. So whenever your traffic is more, in that case you can provide the generalizing island to control the traffic. Now advantage, as we discussed, these are the advantages. Vehicles can be confined to definite paths. The generalizing island provide proper place for installation of signs and other traffic control devices. So if you want to input some traffic signs and other devices, you can put over that island. Refuse island can be provided for pedestrian within the intersection area. Now suppose some pedestrians try to cross that path. Okay, in that case they can rest over that intersection area, and again whenever there is no vehicle they can cross that particular area. So this portion can act as a refuge for the pedestrian. Both the major and minor conflict areas within the intersection can greatly be reduced, as we discussed. Angle between desired stream of traffic can be kept as desired in a favorable way, that is your approach. Angle of approach can be minimized with the help of channelizing island. Then angle of merging stream can be forced to be as flat angles to be cause minimum disruption. That merging angles, okay, merging angles or diverging angles, you can keep it as minimum as possible. And speed control can be achieved over vehicles entering the intersection, as they are forced to follow some particular path, therefore their speed would be automatically reduced. Now there are some basic terminology which is used in the at-rate intersection. So first one is uncontrolled junction. So this is an uncontrolled junction where two major road will meet with each other and there will be no imposition, there will be no traffic signals, no traffic signs, etc. This is uncontrolled junction. Okay, there is no control. Okay. Then priority junction. So priority junctions are, see here two major roads meet with each other. Now suppose another road is there, that is a major road, and it meet with a minor road. Okay, this type of portion is called priority junction. Suppose in your college road, okay, so there is a main road which go towards the Panikhaiti, and there is another road which comes to your college, and basically that road diverges from the main road and connected your college. So basically that type of intersection is priority junction. Then space sharing junction. In the space sharing junction, traffic streams share space at the same time. Okay, suitable for 3 or 4 highways meeting at the intersection with nearly equal traffic. So, for example, rotary intersection. In the rotary intersection, what happened? All the vehicles from the different stream will forced to move encircle a central island. Okay, so at the same time they will be sharing a particular space. So this is called space sharing junction. Then time sharing junction. So time sharing junction means these are operated by the traffic signals. Okay. So the benefits of the time sharing junction or signaling system is it control traffic flow, it reduce conflict at the junction, and it is also safer for the pedestrians, because in the traffic signal what happens, you just stop the movement of the traffic in a particular stream and allow the movement of the vehicles in another stream. So therefore what happens, the pedestrian can easily cross the road whenever there is some stop of the vehicles in a particular stream, and it uses less area compared to the rotary intersection, because in the rotary intersections or roundabout huge space is required for the central island, but in the signalization or signal intersection, in that case what happens, you just need some small place at the roadside to install the signal, that's it, and it will require very minimum space. Is it clear?
দূৰত্ব বজাই ৰাখক। হাত আৰু উশাহ সম্বন্ধীয় স্বচ্ছতা পালন কৰক। মনত ৰাখক অকণমান অসম
Now coming to the next portion, grade separated intersection, and these grade separated intersections are also called interchanges. Okay, now this grade separated intersection is the most expansive type of the intersection because you need to design the intersection at different elevation by means of some underpasses or some overbridges, etc. And you know the cost associated with the overbridges. Now, where these grade separated intersections are provided? On high type facilities like expressway, where there are severe number of traffic or there are number of traffic is very much higher and all the vehicles have to maintain a minimum speed, okay, that more than the design speed. So in such cases grade separation is very much needed. At grade intersection which have reached maximum capacity, suppose the maximum limit of the at grade intersection is the rotary intersection. Suppose this rotary intersection cannot manage the traffic existing over there. In that case, you have to design a at grade intersection. At location of the bad accident history when functioning as at-grade junction. Suppose a particular at-grade junction is there and in that at-grade intersection there are number of accidents is very much higher. Okay, in such cases you can design a at-grade intersection, a junction where the traffic volume is heavy and it is more economic to provide grade separator compared to the delays and loss due to not providing that. Suppose the number of traffic or number of vehicles in a particular junction is very much higher. Now if that is very much higher, in that case there would be very much traffic congestion for a particular longer period of time, and the delay caused by the vehicle would be very much higher, and in such cases you can always provide the at grade separated intersection. At certain specific rolling or hilly topography, in hilly topography, if it is required to provide at grade intersection, you can provide based on the topographical condition if it demands so. Then road crossing has 4 through lanes or more. Suppose a road crossing has 4 lanes and they have very much higher number of traffic. In such cases you can provide the grade separated intersection. Now there are different types of grade separated intersection. So first one is 3-leg design. These are called 3-leg design. Okay, so this is a primary road section and there is another road section. Now here see this portion, see this portion here, the road section meet at a different level. Okay, they are not meeting at a particular or same level, but they are meeting at different level. This type of design is grade separated intersection, and this design is three leg junction. Okay, now another type is four leg design. This is called four leg design. Okay, see there are four leg, 1, 2, 3, 4. This is called four leg design. So the vehicles which want to go in this direction, they just going in the underway and just going around this portion and will meet with the traffic over that area. Okay, so there will be add grade over this portion, sorry, grade separation at this point, but add grade over this point. Okay, this is four leg design. Then this is called diamond interchanges, and this is the most common type. This is called diamond interchange. So this is the road which is over at elevation than the existing these two roads. Okay, so if the traffic wants to go over there, they can simply, there would be some overbridges, and through that overbridges they can reach at this position. This is called diamond interchanges, and this type of interchange is called clover leaf. Okay, this type of interchange is called clover leaf, and this is more expansive than the diamond interchanges. Then there may be rotary design. This type of design is called rotary design. Okay, because there is a central island like rotary intersection, but that would be at grade intersection. And there is another special type of intersection which is called rotary intersection. So this portion we will discuss in our next class. So in our next class we will discuss about the rotary intersection. So we will meet at 1 p.m.